If we want to make a map projection of the entire world and we don't want to use a cylindrical map projection, in general, our lines of latitude and or our lines of longitude are going to become curved. This is one example of a map projection with curved lines of latitude. This was an azimuthal equidistant map projection, so it's projected onto a flat plane, and the one point that touches is the point at the North Pole here. And what we can see is we can see the entire world, both the northern hemisphere inside of the red equator line here and the southern hemisphere outside the equator line here, and both are shown on this world map. However, there is a lot of distortion here in both shape and size. What this does preserve is the distance. So the distance from the North Pole to any place on this map projection is the correct distance. But we can't measure, for example, the distance from New York to Paris. That would be an incorrect distance. It's only good for distances where we start at the North Pole. Much more common on world map projections is to use curved lines of longitude. So in this case here, we have one straight line of longitude, which would be the prime meridian, and is central in this map projection. And all of our other lines of longitude are curved to greater or lesser degrees. All of our lines of latitude, however, are still straight. This is a commonly used world map projection called the Robinson map projection, which is neither equal area nor conformal, but is a compromise which makes the Earth look good. More recently, researchers have developed the equal Earth map projection, which is an equal area map projection of the entire world. So everything on this map projection is represented by its proper size, and so it's very nice in that way. And we can see, once again, this is accomplished by using curved lines of longitude and straight lines of latitude. You can also see that they don't converge at the North Pole or South Pole. We have some distance here where the North Pole would be represented all along this line, and the South Pole would be represented all along this line. We could close that gap and make all of our lines of longitude converge at one point at the North Pole and the South Pole, such as in this Moloweed map projection. And what we can see is now we need to put even more curve into these lines of longitude here. We could even go to the extreme of making the entire world look like a circle, like in this Van der Grinten map projection. And as we can see now, we've made a map projection where the entire world is within a circle. All of the lines of longitude are converging at both the North Pole and the South Pole. The problem some people have with this map projection is it kind of looks like a distorted globe. It's not like a globe in that it shows the entire world, but the shape and how the lines of longitude and latitude look remind people of a globe. We can also see the lines of longitude or latitude are also curved in this map projection. So one way around this is, instead of trying to put the entire Earth on inside of one circle, what if we put the entire Earth into two circles? And this is the Nicolosi globular map projection, called globular because it's supposed to resemble a globe, in which we have one side of the globe over here. This point here is the one point along the equator where the two map projections actually touch. And then the other side of the globe is shown over here. Once again, now we have curved lines of latitude and curved lines of longitude. Maybe looks a little more realistic, but this is just another way to get the entire globe onto one piece of paper as a single map projection.